in Washington, D.C., the capital of the United States of America. This is where all the laws, everything is at. And we are here and Union Station, the center of everything, the center of all transportation on the side of America. In the center, and you know, some people believe that we are the center of the universe, we're the third planet, sun, and another thing. So we're here with NASA today, and I told them, they told me to come over here and they give me the rundown. So we're going to do that, but if you guys can, before we do that, hit that like and subscribe, share the video, because Earthday is very important. Don't forget about this wonderful planet that we live in. And so thank you. So what are you guys doing here today? What are you guys doing here today?
So this is our Earthday event. So
Our Earthday with NASA, or?
yeah, so this is NASA's Earthday event. So there are 24 different stations. They have 3 of them in your head. And if you go to at least 6 of them and get a stamp, you can come back and get a free bag, get some stickers, patches, things like that.
Awesome.
Yeah. So would you like that?
Hey, can you tell me more information on like what NASA had to do with Earthday? Or?
Yeah, sure.
Everything over there, right? Everything, I'll tell you all that we do.
Yeah.
All right. All right. So what's up with this?
That's part of the essence of it.
So you gotta go to all the places in order. Is that why they number? Hey, well, okay. I'll come back and we do it. I think these are high numbers, so I'm gonna go to number 1. So yeah, I think Earthday is really awesome. Leave comment in the video if you guys are environmentally a planet too. Saving the planet is what we do, and I think NASA have a really big role on the Earth. Because of a lot of reasons, because you know they can see the planet, and when we saw the planet for the first time, when we saw the Earth rise from the darkness, dark side of the moon, we know that this is the only Earth, the only chance we had to make this world a better planet. And we had one Earth, one chance, and so that's why I feel like NASA always been part of. NASA and the environmentalists always been a part of conservation of the planet, and we can actually, the NASA really can show the science of this Earth in a way they are able to make the world a better place. Oh, I'm sorry. So, hello, I guess you're on Station 1. I'm trying
You can see the different real, different concentrations, so different species of phytoplankton. Phytoplankton means little plants that move around in the ocean. They are microscopic, right? And you see that they have different colors depending on the species. Okay? So these ones, diatoms, right, are basically like the grass in the ocean. This is what little fish likes to eat. Okay? This one is not very nice. This one is polypsons. So when you have many of these, you have what we call a red tide, or a house of algal bloom. Okay? So the key is that we have satellites right now that let us look at the ocean, and this is what we can see right now. This is a bloom of one of these species. This is a bloom of these guys down here.
The majority of algae is not
right, and these guys are made out of chalk.
beneficial.
Okay? And they are not very edible, so fish don't like these guys.
Yeah.
So in the ocean, when you have these imbalances, with changes in temperature,
No program has been in existence for 20
then you
years.
change basically
But
the
the app.
So my question is, how do you know the color you're seeing here
So one of
is
these
an effect of the biology of the ocean and not the geology of it, right? Because you can have, so you see that discoloration occurs due to like the interference of the light coming out, going all the way back, and the refractive index. I wrote a whole piece on refractive index. Yeah,
So this is biology. We can separate them.
how?
All right, I'm going back up for a minute. So yeah, thank you guys for commenting. I'm sorry I was in the middle of trying to get people. You watched the SpaceX yesterday? SpaceX just launched the. I watched a little bit of it. Yes, I was aware of it. Yeah, the SpaceX just launched the rocket into space. It was really awesome. Ellie in Space was down there watching a lot of it, capturing a lot of it. It was so yeah, it was really awesome. I should definitely finish watching more information out. That do you use a refillable water bottle? Yes, I use refillable bottles. I have a refillable like a 5-gallon jug of water in my car, and I refill it. And I also mainly drink out of so I have one that I got from the Inside channel. Well, Inside, he gave me one that I usually carry with me, and then I also have in the vehicle while I'm driving. I have like a Buc-ee's cup that I refill with ice and soda or iced tea usually, which I keep it watered down by using ice. And it's locally brewed and locally, made. So it's made with local water. So because that way we don't have to track water from around the planet. So that's good. So I'm going to try to cut in here and get the next. Let me get the stamp.
And we could also compare images versus what it actually look like on the ground. So it's
basically tells you. Okay, I figured.
So we got the stamp.
And those are available online. Yeah, I know. There's a lot.
Alright.
Okay. Give it a try and you see what you can do with it.
Alright, so.
And the signals from, so let's say, sort of IR signals.
Ask me how to. What does it say?
What do you want to do? Citizen science.
Alright. Hello. How you guys doing? What are you guys doing?
You want to participate in the land cover?
Yeah.
So, Globe program is where our program is, and Globe Observer is an app. In fact, there's a QR code there. And what you could do is you could participate as a citizen scientist. You could get observations from the ground. For clouds, you could take pictures of clouds and then classify. And then this one is also land cover. Land covers are activity here. There's also one for mosquitoes, especially this summer and spring. Lots of mosquitoes are here. And trees. So trees, we measure tree height and circumference. And if you do that on a regular basis, you could track the growth of trees in your region. Do you want to participate in this particular thing?
You mentioned the clouds and mosquitoes.
Clouds, mosquitoes. But for mosquitoes, it's like getting a picture of, let's say you observe a pool of water, okay, and see there's some wriggly larvae. So take a picture of that and like the modified version of mosquito or mosquito larvae.
So we're at the.
And these are important because the Department of Health particularly is interested in where those mosquitoes are and how we could get rid of them.
So you can see how many trees are growing, how like things like, also like how dry the environment is.
Exactly, yeah. So environment.
Like a lot of, like this year or last year, noticed that a lot more brown. The grass is a lot more brown.
Yes.
A lot of places, like been a lot drier this year than been last year. So
Yes,
you guys can see this. You can see changes in the environment, and you guys can show, hey, this is the way the environment is changing over time. But so we can show proof, that we are maybe affecting it, and how mentally or positive, and maybe ways we can improve it.
Right, exactly. Yeah, it's like a temporal. You look through the climatology of trees. So, did you want to participate? So, this is a Lego activity. So this is like your grid base here. You can move this around if you want, but this is a very interesting river here, Potomac River. So you could capture this square here and make it look like your Potomac River here. You could represent this like a blue,
for the river, and then around it are trees that would be the green, and then this is the airport, right? The Reagan National Airport. You could do that. All right. So, which area are you doing? Is it this
Yeah,
one? All
yeah.
right. Very good. So it's just like averaging your color there.
So over here, we are talking about
So yeah, so you just kind of build a robot, and then
and so
you kind of see.
You can also you could make it look like a three-forking mouth of the Potomac if you want.
Yeah, that's really interesting. I think and then after you get done, you could.
You could also do that.
Yeah, that's pretty cool.
so just with like a cell phone,
Exactly.
tablet,
Okay.
you can go out and observe.
You want that part?
things like the
Yeah.
Yeah. Okay. So number 2.
the atmosphere,
So what are you doing over here?
a little bit. So this is a diagrama of different things that you can do with the Globe Observer app. So if you look closely, we have people taking all sorts of different environmental observations.
Okay.
This fellow over here has his phone horizontal, so he's taking pictures of the land around him and the sky around him. This gentleman here has his phone vertical, so one of the things we do with the app is we can actually estimate tree height by tilting your phone, and the sensors inside your phone record the angle that you're viewing the tree at.
So not only are you gathering data from space, but you're also gathering data from different volunteers on the ground, which is all
Exactly.
go in a big national database that can track changes in the environment and which is in the world around us.
Yep, that's precisely it. And it's really valuable to have kind of those different perspectives, because obviously we can see a lot more data on the ground than what satellites can see from space. But satellites can see a lot more of the planet a lot faster than we would be able to go out and document every single thing. So together, we get a more complete picture of what's going on.
Yeah, and you can see a better overall picture of space. You know, of the environment, because you can look at the ground from space and be like, wow, it's changed.
Yeah, they have.
You know.
A lot of times we can see
So all you have to do is
Like it's also amazing watching time lapse of certain areas and stuff.
and then mosquito habitat mapper and trees. So it's a lot of
Yeah, some people use the land cover tool and they'll actually take observations in the same spot.
and then eventually some researchers
And then
will kind of see like
then you
the
kinda
grass
got-
being
And you can, then it can almost be like a time lapse. Like every day you go to the same spot and take an observation of it. And over time, like you see changes.
Yeah, we have quite a few observations that are just like that.
We have what?
Quite a few observations that are just like that. So there's a school, I want to say we're in Saudi Arabia, who observes every single day. And they actually get a lot of dusters. And so I think we've completed like a time lapse of their sky changing day to day. The dust coming and going. That was awesome.
So, yeah. Michelle, when you lean into
And I guess this is a computer.
yeah, when you lean into all right. So yeah, so it's really awesome. It's really important to observe, see what the world is around it, and see the changes in order to make better changes for the world. So like yeah, I might stop and start the camera because I'm waiting because like I'm waiting for the next guy. I don't want to just be sitting here, like, you know, the camera going for too long. And I gotta call my friend back. I'm not really sure what's going on. There's an app that you can download. What's up with the water bottles?
Oh, Rick said something.
So here we have a little experience about how clouds form. So we have two different ways. We have this bottle. We have a little water in there. It's a bit of match. And as we do that, it's students will squeeze the bottle, add pressure, temperature change, and as they release it, they create that cloud. So in order to form a cloud, you need a couple of things. You need water vapor, you need condensation of cloud, you need something to bond, the water vapor to bond to something. So we add that match to have the smoke be the bonding agent. But then you still need pressure and temperature change. So as you squeeze the bottle, you're adding pressure. When you release it, it's cooling, and then you're creating that cloud. Would you like to do one? Yeah, cool. Okay, go to your let's try and add a match in there. Okay, go ahead and put the top back on.
So the smoke is big. So in order to create clouds, you need something water vapor to settle on.
To bond to.
Bond to.
Yeah, so we have things like smoke, dust, pollen, sea salt, aerosols, things like that. Those are the bonding agents.
Yeah, so you need, so clouds are not just made out of water, but they also made out a slight bit of bonding.
Yes, yes. So now what we want to do is we want to squeeze the bottle, hold it for like 3 seconds, and then release. So you'll see a slight cloud in there.
No, it's like if we do it again.
Yeah, if you put it to the light, you can see it a little better. And then release.
Yeah, there you see the really good cloud.
There it is.
Boom.
And you also may notice as you squeeze it, it's a little warmer, and then you release it's a little cooler. So we're adding temperature change.
Oh yeah, when you squeeze a little more on the way.
So what you can do also is take the red top off, and as you do that, you'll see the cloud coming out of the top.
So that's why high pressure zones are generally warmer than low pressure zones.
Yeah. So we do everything as we do this.
Oh yeah.
There you go.
There we go.
It's very slight, but it's pretty good cloud.
And what was in there that made that?
Let's show the cloud.
Yeah, that was just water and a match. So the match makes the water vapor bond into like water droplets, and then as we squeeze it, we're adding pressure, and it's warming up. And then when we release, the pressure changes and the temperature cools, and then it creates that bond. So you have the mixture of hot air and cold air.
What is this thing for?
This is another one. Let's do this one next.
Okay.
This is a really big cloud.
Right.
We're doing the same thing, but now we're cheating a little bit because we added some alcohol. Our atmosphere doesn't have alcohol, but these molecules are going to bond better under pressure.
So this have what? Does this have it?
This is rubbing alcohol.
Okay, rubbing alcohol.
We swirled it around. Now what we're going to do is add some pressure. So if you want, you can help me with this. Go ahead and pump. Maybe about 5 seconds. I'll hold this and you hold that. Then pump it about 5 or 6 times. So if we have like a barium thermometer on the side, we notice that the temperature is starting to rise.
Okay.
The bottle's harder to squeeze, so it's a little warmer, and that's getting hard to pump as well.
Yeah.
Okay, that's probably good. Perfect. Okay. So let's see what happens when I take the top off. Okay. Ready? 1, 2, 3.
Whoa, and then it turned into an instant cloud.
So all that hot air
What are you
inside
doing?
mixed with the cooler outside and created that cloud.
And what was the green stuff in there?
Just rubbing alcohol.
Oh, really?
Just
Why would it be that color?
So we can identify the difference between water and alcohol. Because if you add the match to the alcohol, boom. So we don't want to make sure we don't do that. But we do want to add the match to the water.
So that's pretty cool.
Yeah, all right.
And that's kind of how like combustion works in the engine as well.
Kind of. There's a lot more to it, but yeah.
Yeah. But yeah, it's a cloud. So why does it have more? So what's with alcohol? Is it because it creates more cloud?
The molecules bond better. So when we add the pressure, they bounce around and they create this more intense cloud. So it's great, like a demonstration of how cloud works, but to make a more realistic cloud, we go with the water and the match.
But yeah, because alcohol bores are more sensible.
You can also use air freshener. So if you want to use alcohol, you can use air freshener in there as well.
Do you have any other demonstrations for us?
No, just these two today. So if you get your card stamped, yeah. So we're number 2. So we're partnered together. So you got your number 2 done already.
All right.
Go
So
to number 3 next if you like. Or
and then so yeah. So are you on the
And this is a volcano, eh? That's supposed to be like a volcano.
It's actually just a mountain, but a lot of
And
people
that's a
have
cloud.
thought that it is a volcano. Yeah,
That is so
it's
cute.
connected.
Wow.
Yeah.
you working as a student? Yeah, you started as a student, but now you've been doing this for 28 years. Wow.
actually 29. Summer working.
Wow.
Maybe 30 actually. But yeah, it started as a summer intern, and then as an academic part-time employee, and then became a full-time employee. Yeah. So that's how I got to NASA, and not one of the things to NASA. Why would you want to leave?
Why would you ever want to leave working for NASA?
Yeah, exactly.
That's everybody's dream to be an astronaut, or like kind of astronaut, or working with NASA.
You get to work with some smart people, and also get to work with the next generation of scientists and engineers as we do these types of events. So it's great. It feels great to be able to
I'm
do
really
that.
glad you guys do this event because I was like, I'm in Washington D.C. Come on, like Earthday.
Yeah, Earthday,
So,
exactly.
you know, so I'm really glad that you guys didn't forget about the planet this year and celebrating it.
Thank you so much. Appreciate it.
All right, have a good day.
Yeah, you too.
Do you have any comments? Remember when we were talking to people, make sure that you get them in the cassette site, even though like you want to hear what they say. Oh, okay.
And it's able to measure really precisely how high the ice is. And
So it's kind of like LiDAR, similar.
It's LiDAR, yes, exactly. Across my radar,
Okay.
and it's just about from 300 miles above us.
Wow.
It's a really weak beam, so it's not harmful to the wildlife or people. But it's still really
Yeah.
good when you see the camouflage.
So you guys, go over everything, kind of scan the height of everything. So
Yeah.
you can measure the amount of ice, and which is really important because you measure the environmental change.
The change over time, yeah. So
How
we
much-
have 90 days to get a new dam set over a specific area. And we get really precise elevation data, so we can tell even slopes of things and stuff, not just the surface. So scientists can learn all kinds of stuff too about processes and things and about the ice, how it moves and stuff like that. So yeah, the main thing is just to,
You know that the Earth is warming and the ice is melting.
yeah, I was just showing the animation about a gigaton of ice.
So yeah, so you want to show me? So real quick,
yeah.
so
I guess you
I
can
didn't,
see.
I couldn't really see because all the people were in the way.
So we're losing about 320 gigatons of ice every year off of Greenland in the northern hemisphere and Antarctica alone, and combined, I mean. And this visual shows the National Mall. If you were to fill it up with a chunk of ice from the Capitol to the Washington Monument, that would be 1 gigaton in volume. But we're losing 320 on average every year of ice. So, but it's hard to imagine what a gigaton is. So this animation kind of really, lets you kind of wrap your head around it a little bit, maybe, but not totally either, right?
Yeah.
So we're collecting data and giving it out to the public so that people can get informed and scientists can,
So people understand that we are losing ice every day and that we need to try to figure out ways to solve that.
Yeah, exactly. Can I give you a stamp?
Yeah.
Just need 3 more.
Well, I gotta get them all. They like Pokemon, gotta catch them all.
Gotta get them all. Don't forget the eclipse booth because we're gonna have solar eclipse, total solar eclipse across America in April of next year.
Wow.
So that booth is over at the heliophysics there in the corner.
Okay.
And then don't forget to grab a NASA calendar in the corner. They're really nice.
So.
I work with NASA for a satellite mission called GPM, which stands for Global Precipitation Measurement. And basically what we high above Earth, and it's like, precipitation. As we fly by, we're able to measure picture what kind of precipitation and how much precipitation is falling. And then we know how much rain we're going to have. Is there going to be a flood? That sort of thing.
So you track where the water's falling, so you know if they're going to be a flood, or you know if the river's going to rise or going to drop.
Landslides, things like that.
Okay, that's really interesting, awesome, because I know a lot of people live by riverways, and they like always worry it's the river going to rise, because it may not even be raining, and then also the river floods, it comes way up. Because you know it might rain, there might be something happening upstream, hundreds of miles away. At times, could affect the river downstream.
Awesome. All right, well, have a fantastic day.
Yep, there's a lot of variables. Enjoy the rest of I'd like to look at this, and this is kind of cool. Like, you can see up here if you have a bunch of snow, eventually when that snow melts, then it will fill like one of those lakes. And then like in California where they had so much snow, then, you know, the lake will get so full that eventually, it will flood. And places that normally don't even experience flooding will suddenly have flooding as it's working its way down. I think that's kind of cool, looking at that, how gravity plays that impact.
Yeah, and rivers are constantly changing, or constantly trying to find different ways. So, like a river could change direction because of a flood. The river been flowing one way for years and years. All of a sudden, the flood and it decided, oh, I like this place, this way better.
Finds a new path. Got it.
You know, and it's like, you know, it's really, really crazy. I watched a show about the Mississippi River, and there was like. They spend billions of dollars every year trying to make sure the Mississippi stays on going through New Orleans instead of somewhere completely different.
That's crazy.
You know, it's like, you know, because there might be a big flood that comes through, and it might send the river going somewhere completely different.
Yep.
And so, so.
No, that's neat. I like shows like that, and it kind of like gives you the big picture. You can understand how it all works in that way.
Yeah, like in the last 100 years, they just put out that you could get a table and run water through it. Have you seen those river tables?
No. Oh yes, I have actually the river table. Yeah.
Where the water pumps in one side, and then you can play around with it, like add a bridge or strain the river out and then see how that's affect the water.
That's so cool. I've seen that like it seems to me there's a Baltimore Science Museum that has that sort of thing, and it was so cool to go there and just mess with it, move the things around. So cool.
So another thing is affected by the waterways is that a lot of the nation is getting a lot drier. Like a lot of the nation is like you see is like a lot more brown and green.
Yeah. I think some places are getting, of course, more precipitation, and some places getting less precipitation.
Okay, so not overall less, it's just changing the precipitation.
Right, exactly.
Which is really interesting.
Yeah, it is. I agree with you.
So some
changes.
places like Europe and America getting crazy droughts that they've never seen before. Rivers are, lakes are dry. Lakes are turning into deserts.
Yeah.
It's just crazy. And then there was all of a sudden the lakes forming somewhere else. So.
Thank you for visiting.
Oh yeah, I need my stamp.
Of course, I'm glad it.
I gotta catch them all.
You're getting there. Thank you very much.
Hopefully I get all the stamps by the time I get over. Alright, can you cut in here?
Thanks so much.
So what you guys are doing here?
So this is NASA Worldview. This is a web-enabled application that you can actually use at home. If you have an internet connection, you can go to NASA Worldview. It's Worldview. Worldview.earthdata.nasa.gov.
Okay.
And then you have access to over 1,000 images in a database that goes all the way back to the year 2000. We have 5 examples today to show you the kinds of things that you can do. So, for example, what you're looking at here, what do you think this is?
I think that it's this is a world view, but it's changing.
Right. So, what do you think this is right here? It's moving.
That's some type of tornado or hurricane.
Close. It's a hurricane. You're right. So this is Hurricane Ian from last year. It occurred in September. It was a significant hurricane because it did 2 landfalls across Cuba, and then it landfalled in Florida. It dumped 20 inches of rain in the central and southern.
And who are you?
I'm not behind the booth. He's not. I'm his boss.
Are you the boss? Maybe you're the person that should interview the most.
No, I'm fine.
Right.
So yeah, this is Hurricane Ian, and this is one example of some of the stuff that you can look at, right? So
Okay.
The next example.
And so are these lines that go across the screen, are those different satellites where one satellite leaves off and one other satellite takes over?
The line, let's see.
So you have these lines that go across.
So what that is, let me show you another screen.
Like why they're like what?
So what that is, this is one satellite, right? This is, if you load Worldview, this is what the home screen will look like. Our satellites are polar orbiting, so when we launch them over the poles, and they move around like this.
Okay.
The Earth moves around like this. So Earth's moving this way. Our satellites are going like this. So our satellites go around the Earth 16 times a day. So think about this. The satellite comes around, makes a measure, and it's on the backside of the Earth. As the Earth's turning, when it comes back again, then you get one of these gaps. Well, we account for that because that satellite's going like this in the morning. We have another one going like this in the afternoon. So this one is covering the gaps that are occurring in the morning, and the afternoon one, the gaps are covered by the morning.
Okay.
That makes sense. Right?
Yeah, because the gaps, because it's bigger around the equator than it is around the poles.
And it is from the gaps because as you're over here, the Earth is still turning. Right? And by the time you come around again, it's turned that much. So you can't measure it all at once because it's polar synchronous. So as you see, this comes down here and stops. This is the last piece that was captured in the last 3 hours. It's called near real time. So 3 hours ago that was captured, and then you'll have another upload. And once you see the next one, that's within the last 3 hours.
How good of the picture? Can you see like houses on this or no?
Unfortunately, we're a scientific research agency, and the best resolution you can get is 15 meters per pixel. Right? You know the pixels?
Yeah.
So look at the size of this booth right now is about 15 meters. That's to say, it's even smaller. So that would be the size
of a pixel.
Of a pixel. And then you have this swath. This is hundreds of miles wide. And so you're trying to look at
your entire house might be one little pixel.
It might be 4 pixels, maybe.
Yeah, maybe, if you have a big house.
Yeah. So you're trying to find a couple pixels in 100 miles. It's
going to be impossible.
That supports that style of investigation.
Yeah, so you're looking at it, it's like your whole property could be a handful of pixels.
Yeah, I mean, the thing is, too, since we're a scientific research agency and we're researching things such as rainfall, we're looking at temperatures and things like that, we're not really trying to go to the pixel, it's covering a vast area. So this is a true visible scene, and so you're seeing the Earth for what it is, you're seeing the clouds. So you're not looking for a pixel of someone's house like here in Africa, you're actually looking at the entire...
Yeah, you're trying to see the big picture.
So we don't support the resolutions of agencies or private corporations that can see all the way down to cars.
Yeah, like those satellites are owned by Google and stuff like that.
Right.
My husband was here. He was
Yeah.
like asking a lot of questions
Yeah.
about the data and stuff. Do you know like which direction he went? He went outside.
He might be looking for you.
Yeah, because his phone died, so now I can't find it.
Well, stay in one area, general area. He might have, yeah.
I sure you come back here. Just hang out. Alright. So you just could try and track the things like rainfall and.
We have a whole bunch of disciplines throughout Earth science, whether it be atmosphere measurement or land or ocean. We do human geography, right? So we track things like population changes and things that are like the human element. There's various. We have other products that are based off of data that go through models, and so we have indices and things for vegetation and populations. So, a vast collection of data. This is just representative of the
And it's really important to capture things like that so you know about rainfall and whether or not it's going to rain tomorrow or where it's going to rain.
So yeah, keep in mind, so weather satellites, what is called geosynchronous. Remember I told you ours are polar synchronous. So weather satellites are run by NOAA, our sister agency. Those are launched over the equator, and they're put in sync with the Earth's rotation. So a satellite stays in one place, and as the Earth turns, it turns with it. So that's why you'll have 24-hour access to weather satellites, and then we have a bunch of them to cover different overlapping coverage. So we don't have active weather satellites because we're a research agency.
Okay, what other things are you researching?
We research a whole bunch of stuff, whether it be earth science, you've got planetary science, you've got over here heliospheric science with the sun. It just depends on what you're interested in.
Awesome. This website is Ward.
Www.earthdata.nasa.gov.
Earth data, yeah. So you did data of the planet.
Thank you. I was going to say I love yours too.
All right, thank you. Okay.
And if you do 6 of the activities, they'll stamp you each one you do.
Depends what you're doing.
We've got like a take-home kit
I guess.
over in the Earth tents where you finish.
Are you Michigan?
Okay, cool. So you hand out count. Is this pretty much just hand out counters?
Yeah, this one doesn't have a stamp with the other activities.
What does that mean? What does it mean? What does it mean? It means nothing, yeah.
Hi. So what you guys are doing over here?
So thanks for coming. So this is JEDI.
JEDI.
Yeah, it stands for Global Ecosystem Dynamics Investigation. It's a joint mission between University of Maryland and NASA. And this is what our instrument looks like. It's about the size of a fridge. And it's situated on the International Space Station. Are you familiar with the International Space Station?
Yeah, the International Space Station. That's where they do all the experiments in space, where people live in space.
Yeah. So that's where our instrument is. So as the ISS is orbiting Earth, our instrument shoots down near-infrared laser beams, which you can't see and you wouldn't feel it if they were over you. But those lasers then measure tree height around the globe. So that is the purpose of the mission, is to measure global tree height. And then from that tree height, you can extrapolate that data and understand things about biomass, like what are the biomass stocks around the globe, how much carbon is stored in forests, and also you can make models that can predict things that might happen in the future with carbon. You can also look at vertical forest structures, so looking at how forests look in 3D, and that has implications for habitat quality and biodiversity and things like that.
So you can see how much biomass is stored up in the forest.
Yep.
How much those forests are growing, so you know, and how many forests is out there. That's really all the things are really important.
All the things.
And yeah, biomass is super important, because that's science, natural batteries.
Yeah.
Storage of power.
Pretty much.
Energy.
And then if we're losing it, then
need to know like what's going on a global scale to understand how much we're losing, what kind of impact that's having, what impact it would have if we were to gain it back, and all sorts of stuff.
Yeah, it's awesome to be aware of these things and how this ghetto thing. So it's
Do
really
you
awesome.
have a thing to get a stamp or no?
Yeah, I have stamps.
Let's do it. You know that if you get 6, you can go get a bunch of free stuff, right?
Okay,
From the
well,
tent. Oh, you already got 6. You're good.
How many do I gotta get now?
If you want to go get the free stuff from the Earth tent, you're good.
Well, no, I'm not. No, I'm here to making YouTubes.
Oh, cool.
I have Erick the Dream Giver. I have a YouTube channel.
Oh, nice.
Yeah. Wow, this guy have a. What are you guys? So what are you guys doing here? You guys got a bunch of satellites out here?
Yeah, so these are tiny satellites. So we're the office that works at making things smaller, cheaper, faster, lighter. So we try to reduce size, reduce risk. So we build cameras or sensors to study the Earth, Earth science-related phenomena. So HARP here looked at aerosols in the atmosphere. So it made very accurate cloud maps. So it's got a special prism inside.
So this is a solar panel?
All solar panels on the outside, yep.
So that's the entire satellite is like literally the size of a.
Yeah, it's kind
they literally could fit in a backpack.
Yep. Yeah. So these are radically smaller than most satellites. Most satellites are the size of like a school bus. So
Yeah.
they can do a lot more, but again.
So the whole point is this: you can launch like 100 of these.
Right.
Out in one mission instead of only like 1 or 2.
Yeah. And if one fails, out of 100, it's not a big deal. But if your $1 billion satellite fails, you're out of luck.
Yeah. So they're a lot smaller. They're also a lot cheaper to get to orbit.
Yeah. Yeah. So there's a lot of ways to reduce risk with these things.
Okay, you could just stuff 100 of them instead of.
I know. Yeah.
Instead of just one. And then is this another miniature satellite?
Yeah. So this is the actual size of this satellite. So this radar antenna would fold down kind of like an umbrella and go up inside of here.
Okay.
Radars are typically much bigger. They're very power intensive. Take a lot of power to get the radar signal all the way down to Earth and then back, reflected back.
So this
is a proof of concept that you could do it on a platform this size.
So there's a weather radar.
Yeah. So it looks at how much water it passes through. And you use that as a proxy for the rain.
And so what is this, another satellite?
So this is one of the first small satellites that NASA sent up. This is the actual size of this as well. So this was kind of a prototype to see if you could even do anything usable on a platform this size. So we did some data processing on this. It had basically a glorified cell phone camera on the side. We went up and tumbled around, took images, processed the data, and then downlinked the data. So it's just to see if we could track it in space, track something that small, and get data down, usable data.
And why did it have these? Are these were the solar panels or something?
These are the radio antennas. So they actually use Stanley tape measures for the antennas because they needed a material that could be very flexible, but on space would maintain its rigidity. So it wrapped around the satellite, went up to space, and then expanded out, and they use it as radio antenna. A lot of the early satellites just used a $2 antenna or $2 tape measure for that.
It's crazy that you think NASA would be like, oh yeah, they custom made everything for just for NASA.
Yeah.
Like every little thing got to be custom made for NASA.
No, you can tell like the researchers were in the lab and they were like, well, this works well. Just use a tape measure.
And then you can also see how big it is by the tape.
I know exactly. Yeah, good for reference.
Good reference. How big is that? Oh, there's a tape measure on there.
yeah. Measures the tilt. Yeah.
This measures the tilt. So that's really awesome.
Still, like, I guess the early ones are like collaborations between universities and were really collaborations between like the NASA centers and universities. But like, has most of the small sat program gone towards like universities and the commercial side, or is it still being produced mainly in the centers? Like,
it depends. I mean, this is a center, the Jet Propulsion Laboratory.
What is this thing?
So this is a 3D model of a small instrument that would one day be able to fit on a CubeSat. Looks at air pollution. 3D printing allows us to print the internal structure in very precise ways that we wouldn't be able to achieve if we were just bolting things together. And this is Johns Hopkins, so not quite a center, kind of in between.
An APL is essentially.
So
it
suck up small particles from space.
So this is it's another imaging device. So it images air pollution. I think it focuses on nitrogen oxide.
Okay, so not like sucking.
No, it doesn't pull anything in, like no part of just the light.
Yeah, because I know there's still particles in space, not as many, but there's.
Right, there are some air particles up there. So that's what actually causes these guys to deorbit. They're put in an orbit, but slowly they bump into enough particles that it slows them down, and their orbit will decay and they'll burn up in the atmosphere.
Yeah. So, okay.
Yeah, we'll fund anybody. So,
is the funding mostly through the NASA STP or is it all through science?
The thing it does is each pixel here of this image is a piece of data, and we have to stitch them all together and collect what we want to make an image like this.
So this is like props, so you can let farmers know how their crops are doing.
Exactly. Yeah, so a spectral signature might look something like this. This is the amount of light that's reflected from each pixel here. So this would be like a lot of green, a little bit of yellow, a little bit of blue. So if you want to play this game here, we have these spectral signatures, and you can try to line them up with each image. Would you like to play?
Okay.
So from each image, we just take one pixel, so you try to match the color to each one. So this would be a green pixel, a blue pixel, a black pixel, an orange, and a red. So yeah, that one doesn't have a lot of light reflections at all. So most of it's being absorbed.
Probably like this.
Well, so if there's no light in it at all,
this probably
it would be closer to black. So since there's no color in it, it would be closer to this one.
Okay, so this is not an easy game.
No, it's taken me a couple times to figure it out. So what's the most color on that one?
I would definitely scan that.
The most color is blue.
Exactly.
So
the blues, this one's a blue. That'll just take you one pixel from this one. Alright, and then this would be green, orange, and then red from that one.
there's a good amount of blue, but also green. So there's a lot of green here too.
So yeah, you're just worried about this pixel right here. So this one's red, but the green one's over here. This would be the green.
Oh, the pixel in the middle?
Yeah, exactly.
You know, Eric, I don't think I've eaten anything today. No wonder. Maybe.
And then this is green and a little bit of red. Maybe this one?
Yeah, exactly. And then process.
There you go.
Awesome. Thank you for playing. Did you have a piece of paper, like a stamp?
Yeah. So you guys do this all the time?
We do it every Earthday. We come out here to Union Station. But we travel around and do these things in different places. So.
How do you figure it out again?
Where's number 8 at?
Number 8?
So tell me about what you guys are doing.
Hi there. We're attached to this table here. So this is called the satellite, the Landsat satellite. And this is related to using
So this one
here it's mostly just showcasing how mode everything works using puzzle pieces. Originally yesterday we had this piece below using color by numbers, so stickers, instead of color by numbers, so thinking by numbers. And this is underneath the representative of the island of Fiji. And then the puzzles themselves are just another representation. This was done within a day.
I think
So you kind of take a little one picture of a large area, and then you kind of make a puzzle to try to match this up with that.
Exactly, which is really what imaging is involved. It's when you're creating an image, it's not just one picture. It actually requires you to stitch multiple different squares together to make it into a single image that we see like right here. That would be a lot of different squares that they attach to.
Yeah.
Yeah, like a puzzle. So yeah, that's what this is. You also get a stamp. I don't know. Did you get the 2 stamps?
Yeah.
Yeah, you did.
Yeah, you got. I got 10 too. Yeah.
Yeah, you got 2 in 1 then.
All right.
They intended to be a 15-year-long mission, so it's more than doubled its expected lifespan. And so we're hoping it can go at least until the end of the decade, and maybe even into the 2030s as well. But it's about the size of a school bus and weighs 27,000 pounds. It's about 335 miles above the Earth's atmosphere, and so it goes around the Earth once every 95 minutes.
And they're taking pictures of stars and stuff like that. These pictures, right? All these famous pictures that people see of stars. That Hubble's kind of.
Yeah, many of the most famous space pictures that you would have seen over the years have come from the Hubble telescope. So not all of them, but many of them. So, and so it can take pictures of things in our solar system, like this is a crater on the moon, and it can take pictures of clouds of gas and dust and stars like this, and then it can picture entire galaxies and even groups of galaxies too. And this is the actual picture of Hubble above the Earth.
And this is a miniature Hubble.
Yeah, so it's a model showing what it looks like basically. So the wings have solar panels on them, so it's an electronically powered telescope using the solar panels. One of the arms with the dishes on it fell over, but basically it has 2 arms that stick straight out with communication dishes, and that's how it talks. That's how we talk to it from the Earth, and it talks to us by sending out signals there. And then the thinner part of the telescope, the long tube, is what has the mirror in it, so that's what collects the light. It goes through the tube, the mirror is at the bottom of the thin part, bounces back to the top, and then comes back to the bottom through a hole in the middle, and then all the different devices and cameras and spectrographs are in the thicker part that's the lower part of the telescope.
And did it fold itself, and then it has these solar panels on it. And it was all pretty much probably folded up real small when it came out.
It doesn't fold up, but what it does do is the wings move, so they turn so that the panels are always pointed towards the sun. So it can turn 360 degrees so that even as Hubble turns this way or that way, the solar panels can face the way that the sun is.
When it was getting took off, panels had to be attached by an astronaut.
Yeah, so originally they attached the first set of solar panels when they launched the telescope, so it had solar panels to begin with, but astronauts went up to the telescope 5 times to service it, update it, fix things that were broken, and so one of the things they did is replace it with new, better solar panels that got that electricity better, were more efficient,
okay, that's pretty awesome.
Yeah, so they did the first servicing mission in 1993, and then the final one was in 2009.
And you are working on getting maybe another service mission to work, that way it works for the next decade.
Well, we'll have to see, because the one in 2009 was planned to be the final one because it uses the space shuttle program to get the astronauts up there, and the space shuttle program isn't running anymore. So we did know when we went up there in 2009 that was going to be the final servicing mission, but we just fixed as much as we could, and it's still been running really well since then. So.
Okay. All right. Awesome.
Yeah, thanks for stopping by.
So this is a 3D model.
Yeah, so you can move your hand over like this, and you can actually use both hands too and move this model of the telescope.
Wow, this is pretty cool.
Might have to hold your hand a little higher if it's not working, but
yeah, this is pretty cool though, because it's actually like a hologram too. Like you can literally see it differently depending on how you look at it.
Yeah, so it lets you see the telescope in all sorts of different angles.
And it's also 3D too.
Yep, yeah, it's a 3D projection.
And what's in here?
So these are augmented reality. You can point any of these iPads at any of the framed pictures and you see them come to life.
Okay.
So you can play with a 3D model. This is the Hubble Space Telescope.
Oh, wow.
And on Monday, Hubble is going to be 33 years old. So it's been up in space for that long. It's about the size of a big school bus, and it goes around the Earth once every 95 minutes. It's about 335 miles above the Earth. So, oh yeah, I can give you your stamps too. Thank you. And you can get as many stamps as you want, but once you have at least 6, you need at least one more. You can take it back to that tent and you get free stuff.
Okay, gotcha. Thank you very much.
Several, yeah.
We also have augmented
Do you got my D stamp me?
Oh, sorry. Yeah, I can get you a stamp too. Yeah. So you can point these iPads.
Good. Hi. How are you doing?
Good. So this whole table is the American Geophysical Union, and
Okay.
we're an organization of Earth and space scientists. So some of our members are NASA scientists, and our members work on all kinds of Earth science work, geoscience, all the way from the center of the Earth up past the exoplanets, all sorts of Earth systems in between. So we love science education. So what we have today is coloring sheets and coloring activity.
And they call it AGU?
AGU, the American Geophysical Union. But we're actually global. We cover more than just geoscience, and we're not a union. So that's why we go by AGU. So, yeah, so if you want to color, or if you want to take some coloring sheets and crayons to do it later, up to you.
Okay.
Yeah. So we don't have an experiment, but we've got kind of a nice meditative activity.
Okay, cool.
Yeah, absolutely.
Do I get a stamp?
Yeah, you do. Let me stamp ya.
So, hey, how you doing?
Actually, this kind of place need more vaccine than here, but actually more vaccine is to
Okay.
big cities.
Yeah.
Really don't.
So, can you tell me about what you guys are doing?
Actually, human mobility.
What?
Human mobility. Like during the COVID, like the human mobility drop and start to recovery. We have the first vaccine and the second one. But it does not happen at the same time. Like some places, they have more vaccine, they have higher vaccine rate, and some places they have fewer. And the mobility keep at a pretty low place. Yeah, this kind of place gonna need more vaccine during that period.
Awesome. So that's really awesome. So there's the crafting of the vaccine, and what's he talking about?
She studied animals pattern.
What?
Animals mobility pattern.
Oh, the animals, how they migrate, migration patterns of different animals. Oh, awesome. So hi, what you guys are doing?
So we're doing satellite servicing at Goddard Space Flight Center.
Okay, so you do satellite servicing and data?
Pardon?
You say and data?
At NASA. So
At
NASA's
NASA.
Goddard Space Flight Center.
So, so you're pretty much showing how these robots are like the robots that like service the space
Yeah,
things
so
in
these are
space.
designed by some of our interns. They're just meant to give people an idea of what it's like to pilot an arm.
Yeah, so like arms are used on the like to do different tasks. So like people didn't have to go outside and move things.
So arms are specifically for servicing, so refueling, retrofitting, that sort of thing. Arms can also be used for sample collection, for berthing and docking, all sorts of things.
Oh yeah, docking. So when it would like somebody show up, you grab the space shuttle and bring it over and dock it.
Yeah, exactly.
So that's pretty cool. Okay. That's really cool. So yeah, I've seen a little bit of this. How accurate is it?
This one's not super accurate. This is just a commercially available one that we use for demos. The actual vision systems we use are pretty accurate. They're
So you can
very
see it.
calibrated and
So they,
designed specifically for the purpose.
and what you use these for? Just a demo?
Computer vision systems for the robots.
Okay. They can see like something that's a different, usually something at different degrees than other. So you can see things supposed to be. Oh, that thing is hot, so that must be the spot.
Yeah. We also have like regular standard vision systems and LiDAR, so light detection and ranging.
Okay, cool. Yeah, that might be work. Like you can make like you can like heat like a knob to a certain degree. So like, oh yeah, I'm looking for that knob. You heat it to that degree, and you can heat something to like, you know, you can heat something to something pretty accurately.
Yeah, generally we're just detecting like what existing heat is on something. We don't really like add heat to something different using this system.
But I'm just saying you could heat something to have as like a beacon to like, oh, that's something I'm looking for. That I'm looking for something that sensible, real basic. We're like, oh, that's 92 degrees. I'm looking for something that's 92 degrees to grab onto.
Yeah, you could. Yeah.
And then make it easier for the robot to identify something. You know, by using infrared because it's supposed to be a certain degree, like control heat to the system.
In general, we don't like heat up something so that we see it differently. We just use the existing heat that
Oh, this is cool. What do you guys do here?
Yeah, so I'm here with half the Earthday Applied Sciences team. We're talking about our recent comic strip that we hosted. It was an international contest that invited youth and adults from around the world to participate. Winners within the water division. They took an original applied sciences story and designed it, scripted it, and won. And then here's the second one with wildfires. So our activity today, we invite anyone who's interested to read their own comic. We kind of already started because they've been coming around yesterday and today, just to tell their own story about how they're celebrating Earth Day.
Okay, so you could make a story, you could submit it, and then if you win, you get put on the website.
Yep, you get put on the website. It's shared on social media. You're sent comic that's printed on really nice paper, a certificate. So we plan on hosting a similar to later this fall. So if you're interested in learning more, we have QR code here to our Applied Science website.
Yeah, definitely get that. That'd be really cool. So you're the marketing one.
Strategist. So I help think of new campaigns or other ideas that we can execute to get people interested in our work and educate others about it.
Yeah, so that's awesome. So yeah.
Thanks so much. Do you have a sheet? I can sample for you.
Yeah. So I do a lot of campaign stuff too. I've been doing Earthday festivals every year for like 10 years, and I've been working on campaigns and stuff. It's very hard. Like I feel like a lot of people just kind of forget about Earth Day.
Yeah.
It's like, okay, isn't it just another day? I'm like, yeah, you don't say that about Valentine's Day or Christmas.
Right. No, it deserves to be celebrated.
You know, the Earth is really important and it deserves to be celebrated. And I really one of the things I think we need to do is market to make Earth Day a national holiday.
Yeah, that would be great.
Because not only is schools going to be out that day, but the stock market would be closed. Think about every stock trader have to be like, oh, it's Earth Day. I can't trade stocks today. I have to celebrate Earth Day. That would be like mind blowing for every single stock analyst out there. The New York Stock Exchange is closed.
Yeah.
I have to celebrate Earth Day. That alone will be like game changer.
So I hope you have something fun planned tomorrow for Earth Day. We're celebrating a little bit early, but
I mean, I'm glad you guys are out here. I came all the way out to Washington, D.C. to celebrate Earth Day. It's been one of my dreams to be in Washington, D.C. for Earth Day. And I'm glad to find you guys here.
Yeah, no, glad you could attend. Make sure to get your prize from the Earth Day too. Here.
So I have an organization called the Rock Club Foundation. I'm Erick, the Dream Giver.
Oh, okay.
So the Rock Club Foundation, I bring people together to make the world a better place, find dreams and make the world. And then I have to have the, an American the Dream Giver, so I help people find the dreams, and then the Rock Club Foundation try and bring people together to make, bring dreamers together to make the world a better place. So yeah.
And this one is total solar eclipse. And this one is April 8th. And this is the path of totality radiance.
Okay, and then when this year?
So this one is this year, this one is next year.
Okay. That's crazy, the two eclipses happening.
Yep, and this is going to be the last one that you're able to see in the continental U.S. until 2045.
Oh wow, that's great. So this is going to be in October?
Yes, this one is October. Yep. Those are all the places where you can see the best.
And where's like the best place that people think it's going to be?
In Texas.
Austin?
Yeah, Austin, San Antonio.
Yeah. So Austin's the place to be, it looked like.
For both, yeah, they're special.
You know? So that might be something to that. I don't know. So, and these are the solar eclipse glasses you put on. These are like really heavy duty sunglasses that you have to wear while. Because I actually was in Kentucky last year for the
2017, yeah.
2017. I bought my bus down there, and yeah, it was really awesome bringing my bus down there and seeing that eclipse. All right. So, are you also talking about the eclipse? Alright. Packing up. What, can you give me the spiel real quick before you leave, or no?
Well, I turned off everything, but this program is called NASA Eyes, EY Eyes, and you can Google it. I'll give you a card.
Okay.
You have access to a computer?
Yeah. And with that NASA Eyes,
it shows you all of the different satellites. The one will show you.
so yeah, you get to see all the different satellites for free.
Did you get your Earthday stuff? You still got the stuff of the 1 to the 10.
Yeah, I'm trying to get all the stamps. Well, how am I supposed to get all the stamps?
You've got enough. You only need a 6.
Okay. I'm sorry it takes so long, but I've been here for 2 hours. It's over. I've been here almost the whole time interviewing everybody. I couldn't get to everybody, but I got to a lot of people. That was really most important. Say, so before we go, I think do we have time for one more? What do you guys do?
So this is the OSIRIS-REx asteroid sample return mission. We launched in September of 2016. It took about 2 years to fly out to this asteroid called Bennu. Studied it for about 2 years. Then in October of 2020, we landed at the most interesting spot that we could find that was also safe. Took about 1 pound of material off of the surface. And then in May of 2021, we left Bennu and we've been flying back to Earth ever since. And on September 24, this little piece of the spacecraft will come back to Earth and land in Utah. And then we'll study the material that we took in labs here on Earth.
So how big is this spacecraft?
This is about 7 feet on the side, so it's, a little taller than I am. These are the cameras I was responsible for. These you get to hold in your hand.
So you help build this? You help build the cameras?
Yeah, I was responsible for these 3 cameras, and then earlier on there's a spectrometer called OVIRS that I was also I had to build the optics. So September 24 this year, it's
one will be back. So it should be in the press quite a bit. It'll get a lot of attention. All right, Austin.